overheat. In other words, they grow too fast and they generate inflation. In which case, what should the government do? Well, in that case, it has to take money out of this economy. It has to slow the whole circle down. And the way to do that is, on the one hand, increase taxes and to lower spending. Lowering spending means that less consumption can take place. And increasing taxes likewise means that households have less income. And therefore, the whole thing can be slowed down and hopefully kept on an even keel. Now, all of that is very instructive, but one of the things that should be evident is that all of this, in accordance to the School of Economics, can go on without ever having to reference anything outside of households and firms. The environment, for all intents and purposes, does not exist. And one way that economists deal with this is that they call environmental effects, to a large extent, externalities. Your textbook uses that term in a slightly different sense as well, although it basically means the same thing. Externalities in economics means things that happen that don't influence the bottom line, either of companies or of businesses, particular companies. So that a company can calculate its cost of production on the basis of the wages it has to pay, the resources it has to purchase, the machinery it has to purchase. But the fact that its smokestack is destroying a huge swath of forest adjacent to its land doesn't affect its bottom line at all. It's an externality, and therefore does not affect its decision-making process. If it doesn't affect its decision-making process, because it doesn't have an impact on its profits, it's no surprise that firms would choose technologies that optimize all of the other aspects of the production process, but will pay no attention to what it does to the natural environment. And then it's no surprise that we end up adopting technologies that have a profoundly negative impact on the environment, basically because, from the point of view of economic theory, it's irrelevant. It's external to a decision-making process. Of course, not everyone has taken that without criticizing it. And in recent years, there has been a growing field within economics called environmental economics. And environmental economists have tried to correct this basic oversight on the part of the more simple model by producing this kind of a diagram of what the economy is and how it relates to the natural environment. In this case, we have the environment at the top over here and the economy at the bottom. And all we need to do is to describe the relationship between the environment and the economy. And it's a pretty simple one. Essentially, they argue that the environment provides resources that flow into the economy. The environment also provides energy, which flows into the economy. The reason that energy is pointed this way downward, whereas resources is out here, is because, as you can see, the entire thing is circular. But the flow of energy can never be circular, because despite the fact that the first law of thermodynamics states that neither energy or matter can ever be created or destroyed, and that is certainly true of resources, and it is certainly also true of energy. Energy is also subject to the second law of thermodynamics, which is essentially the law of entropy, which means that while energy is never actually created or destroyed, it is degraded in the process of being used. In other words, highly concentrated forms of energy, such as oil, that contain chemical bonds that contain energy, when those chemical bonds are broken and the energy is released to heat water or to pump a turbine or something along those lines, what is created instead is carbon dioxide and waste heat. The amount of energy is still the same, but the waste heat can no longer be available for use. And thus, the law of entropy is essentially indicates that in a closed system, a system will always tend toward chaos. In other words, order will always break down. An ordered state is energy in a concentrated form, like a lump of coal. A disordered state is that dissipated energy in the natural environment. And the only way you can get from that disordered state back to the more ordered state is with the injection of more energy. I don't want to bore you with physics too much. Suffice it to say that from this point of view, the suggestion is fairly clear. The only thing that the economy does is turn resources into wastes. That's it. From an environmental point of view, that's all the economy does, is turn resources into wastes. And that's a pretty unflattering picture. And you might go, well, wait a second, that's nonsense. How can you say that? Aren't we sitting in a nice room with nice chairs and so on and so forth that the economy produced? Isn't that something other than turning resources into waste? Well, yes. In other words, the economy does create products such as this room, such as the clothes, such as the laptops on your tables and so on. But eventually, these likewise turn into waste. And from that point of view, essentially, those wastes can have two fates. They can either be reabsorbed back into the environment, or they can be stored. Insofar as those wastes are stored, what we have is a linear industrial metabolism, in which resources flowing on one side and wastes flow out the other side. And insofar as that's the case, the growth of such an economy within a finite system like this planet has obvious limits. There's only so many resources, and there's only so many places that you can store waste. And by storing waste, I don't just mean landfills. There's a number of different ways that the environment deals with wastes that it cannot reconvert into resources. In other words, that cannot be broken down in the natural system. And there's large numbers of those kinds of wastes, in particular in the forms of chemicals, the thousands of chemicals that we've developed, especially in the last 50 years or so, that essentially have no natural enzymes in the natural environment that are capable of breaking them down. And that means that biological systems deal with them by storing them. Your body deals with them because it can't break them down and therefore can't digest them, can't get rid of them. It stores them, and it stores them for the most part with fat cells. And that means that today, most human bodies at the time of their death have high enough concentrations of lead, PCBs, mercury, and so on to qualify as hazardous waste. Some people that are living qualify as that too, but that's another thing. You get the general picture. Generally, the adage in the waste disposal industry was that the solution to pollution is dilution. In other words, if you have these wastes, you just spread them out in the environment, and it's enormously huge. They become irrelevant because they'll be in such low concentrations that they won't cause a problem. The problem with that is that within environmental systems, things that can't be broken down, just as they do within your own body, accumulate within bodies. In other words, they bioaccumulate. And the upshot of that is that, for example, in the Great Lakes system, if the water in the Great Lakes system has a concentration of PCBs that's 1 per billion, that means that the algae or the bacteria growing in that water will have a concentration of 10 per billion because it accumulates within their biological structures. The various algae and so on that feed on the bacteria will have a concentration of 10 per billion. In other words, every step on the food chain, it roughly increases about tenfold. And by the time that you get up to hawks and eagles and so on and so forth, the concentration will be such that, as they discovered with DDT, it prevents them from reproducing because it makes their eggshells too weak and so on and so forth. In other words, these things do concentrate at various points in the natural environment. You get the general picture. It's pretty problematic. But perhaps one of the solutions to that is that, as I pointed out, in the distinction between a linear and industrial, when I pointed out the notion of a linear industrial metabolism, one in which there's resources flowing in one end and wastes flowing out on the other end, one solution might be to aim not for linear industrial metabolisms, but rather for circular industrial metabolisms. And indeed, ecological economists, as well as ecologists in general, have pointed out that insofar as that there are economies in nature, they are all circular in nature. In other words, there are water cycles, there's carbon cycles, there's soil cycles, and so on and so forth, each of which consists of a cyclical flow of materials and energy, one that is by definition sustainable. So essentially, what we need to do to overcome this at the root is to convert our economies to making use of technologies that are more circular in their industrial metabolism. One way of doing that is nicely illustrated by an experiment in Denmark, in Kalundborg, Denmark, and I won't bore you with all the details, but essentially what they set up is an industrial park that started out with a power plant that was producing, on the one hand, various forms of ash that were polluting, and on the other hand, a great deal of waste heat. And they wanted to pump that waste heat into an adjacent bay, but the fishermen found that as it was being pumped into the adjacent bay, the water temperature there was rising and killing off all the fish. So that was no good either. And instead, what they started to do is that they started to figure out, well, what can we do with these waste streams? And on the one hand, figured out that they could make plasterboard out of the ash that came out of the plant. Secondly, they figured out that they could use some of that waste heat in order to fuel a brewery. And eventually to hook it up to the town's heating system, so that they no longer had to run individual furnaces and so on. And by doing so, essentially recirculated those waste streams within them. That's a fairly small experiment, but you get the general picture. Circular industrial metabolism. The problem with all of this is that if we think about circular industrial metabolisms and where they have existed, they've existed throughout most human history. Most human history, humans' economy, was part of that natural cycle. In other words, the economies of traditional societies essentially used resources that were in plentiful supply without exhausting them, and in the process of consuming them, produced wastes that were readily possible to reintroduce into the environment by composting and so on and so forth, and by doing so, turned back into resources. And consequently, were to a greater or lesser extent sustainable, certainly a lot more sustainable than our current way of life is. The problem with a lot of the talk about development is exactly the opposite though. Essentially what the whole emphasis of development is to convince societies of the global south to follow the patterns that were established by currently developing societies. In other words, to imitate their processes of consumption as well as production. And that points away from the more circular industrial metabolisms that still exist in many parts of the third world, and pushes them further and further to less and less sustainable arrangements like those in the current first world. A good example of that is in studies of Ghana, for example, in Africa. They had a bunch of waste, of North American waste management officials go to Ghana to advise them how to deal with their waste streams to prevent them from causing pollution. And they came there with their various recycling technologies and so on, and how to sift waste into different categories, separate the metals from the plastics, from the glasses, so that all of them could be reused and used in a more cyclical manner and a more. But the problem that they encountered is that it didn't seem to work in Ghana. Now, why would recycling technology that works here not work in Ghana? The upshot is that in the Ghanese waste stream there was virtually no glass, there was virtually no metal, and there was very little in the way of plastic. Why? Because Ghana is a very poor country, and glass and metal are very expensive items in those places. Meaning that for the most part, people didn't throw those items away. They were already recycled separately from that. And instead, virtually all of the waste that did end up in landfill was of a more biological nature. Was in that sense very different from that in North America. The other thing that they could discover is that Ghana is very different from places like Toronto, for example, or New York, for example. A city like Toronto has a massive infrastructure that is essentially dependent on bringing resources from thousands of miles away into Toronto. So you can eat blueberries in February and grapes in March and so on and so forth. Flown in from South Africa, from Chile, and you know the whole picture. And then has an equally elaborate infrastructure to haul all the waste that come from that back out of the city. And Toronto is not particularly good at storing its own waste. It has an extensive recycling program, but the majority of that recycled stuff still ends up in landfills, and the landfills around Toronto are all full, so it gets shipped to Michigan and various other places around the world to be disposed of. In Ghana, they discovered that this didn't seem to exist. That Ghana, the main city of which is Accra, the city of Accra was entirely self-sufficient in fruits and vegetables. Entirely self-sufficient. Now, how is that possible? Basically because if you travel through a crop and you look in people's backyards, every single little tiny plot of land, even if it's just this big, is used to grow tomatoes, to grow cauliflower, to grow various kinds of vegetables. And all of that supplies the local vegetable markets, meaning that they're more or less self-sufficient and therefore that much more sustainable. You get the general picture. And this is obviously a much more complicated issue than simply dealing with free riders in trying to put a band-aid on cancer in the form of regulating carbon dioxide emissions. It requires a fairly major reorientation of how we deal with environmental crises. Now, let me abandon this here for the moment and get the projector going. Now the reality is that our environmental scarcities, our environmental problems, are to a large extent a result of this linear industrial metabolism in all of its various manifestations. And this has come to the attention of the international community in a number of different ways. Most prominently, it came to the attention of the international community in what became known as the Club of Rome. In other words, an attempt by industrial societies to study the impact on that human societies were having on resources. And this study was done in 1972, and it came up with some rather alarming conclusions. It found that, well, basically the easiest way to calculate the impact that human societies were having on resource supplies was to look at the known stores of certain types of resources and the rate at which human societies were using them up. And by doing so, estimate how long the supply was still available to sustain future generations. And they came up with rather alarming figures. Essentially, they found that on the basis of the known quantities of zinc that were available in 1972, the planet would run out of zinc. Pardon me, I think it was tin. That was tin. That was not zinc. It was tin. On the basis of the known reserves of tin in 1972, they estimated that the planet would be completely out of tin by the mid-1980s. And that this could spell disaster. Insofar as tin is a pretty important resource in all sorts of industrial applications, and in part also because at the time most food was stored in tin cans and things along those lines. Finding a substitute for it would be rather difficult. They came up with similar figures, but not nearly as alarming on a number of other issues, like iron, like oil, like a whole slew of other non-renewable resources. Indeed, one of the first to blow the whistle or to blow the alarm in regard to resource depletion was a geologist who first noted what became known as peak oil. And he essentially was studying the pattern of using oil in various places and studied the first places that oil was discovered in the United States, which was in Pennsylvania, and found that in Pennsylvania, from the time that oil was first discovered to the peak of oil discovery, took about 30 years. And it took another 30 years from there until you reached the peak of production. But once you reached the peak of production, it fell off rather drastically thereafter. And then he figured, oh, well, that's an interesting pattern. Let's see if it works out in other places. And then he looked at the second place that oil was discovered in the U.S., which was Texas, and found exactly the same pattern. 30 years from first discovery to the peak of discovery, another 30 years until the peak of production, and then a rapid drop-off. And on that basis, in the 1950s, he looked at the United States as a whole and calculated that in the United States as a whole, therefore, the peak of discovery was sometime in the 1940s, and therefore he calculated that the peak of production would come sometime in the 70s, and then after that fall drastically off, and the U.S. would be out of oil. He was laughed out of his profession at the time, in large part because when he made that prediction, the United States was by far the largest exporter of oil and largest producer of oil on the planet. and the going wisdom was that he was out to lunch. It turned out that he was absolutely right. Oil production in the United States did peak in the 1970s and did drop off drastically thereafter. It's had a renewed comeback for complex reasons that we'll talk about in a few minutes. Suffice it to say, essentially the Club of Rome warned that we were on an unsustainable path, that we were rapidly exhausting resources that would be vital for future economic activity, but they got almost everything wrong. And that was a big blow to early concerns for sustainability. One reason that they got almost everything wrong is that they focused on the wrong category of resources. Why they focused on the wrong category of resources is kind of interesting. It seems natural that you would want to focus on non-renewable resources. Non-renewable resources, by definition, are not renewable. You use them up, they're gone. So it's absolutely natural that you would focus on them and think that they were the major problem. But as many of you are probably aware, we have not run out of tin, and we probably never will. And we have not run out of oil yet either. The problem with oil today is not that there isn't enough supply, it's more that we can't burn the oil that is there because it causes other problems elsewhere. But it's not the supply of it that is problematic. And the reason for that is easy to understand, again, simply on the basis of economics. What do you think happened to the price of tin the moment this was announced? Or tin futures, to be more specific. Well, with the announcement that it was going to be out of, that we were going to be out of it in 10, 15 years, the price of tin went up dramatically. And what does that do? Well, first and foremost, it means that places that you didn't bother looking for tin before suddenly become worth exploring for tin, because at the lower price it wasn't worth digging it up in places where it was in very low concentrations. In places at a higher price, suddenly it becomes worth doing so. Good illustration of that is that at the turn of the century, it was not considered economically viable to mine iron ore that had less than 15% iron in the ore. Today, we mine iron ore at less than 3% iron ore in the ore. In large part because the value is different, and again, because we don't worry so much about the waste, although perhaps we should. And a lot of that has, of course, to do with the price of that resource going up, and therefore making it profitable to extract it at 3% rather than only at 15%. So you start looking for the resources in places where you previously couldn't find it. What's the other effect that a higher price of tin almost immediately will have? Well, those that use tin are going to be more careful about using it. If it's worth next to nothing, you can use it for all sorts of purposes. You can throw it out. You can treat it fairly carelessly. If it's at a higher price, you're going to be more careful in using it. Meaning consumption goes up and the supply goes up as well. Lastly, at a higher price, suddenly there's all sorts of cheaper substitutes. So you don't use tin for containing soda, for example. Instead, you put it in plastic bottles and things along those lines. And again, the use of it goes down. And in that regard, with respect to non-renewable resources, the capitalist market, to a large extent, was able to deal with these kinds of shortages by creating the kinds of incentives to make sure that we don't run out of it. Doesn't mean that it was without problems. Obviously, mining ores at 3% creates a lot more pollution than mining it at 15%, and is only profitable insofar as the company that does the mining doesn't have to take care of the waste products that it produces in the process. But running out is not likely to be a problem. The problem, in terms of running out, instead, was with regard to renewable resources, which were not essentially studied or included in the Club of Rome studies. Now, why would renewable resources be problematic? Aren't they renewable? And doesn't that mean, since they're renewable, that we don't have to worry about running out of them? Well, the easy answer to that is that's not quite how it works. Renewable resources are renewable only insofar as that they are treated in a way that keeps them renewable. And the best way to think of that is the way that you guys all think about your trust funds. Now, your parents all set you up with some trust funds, I suspect. No? You guys don't have some trust funds? Oh, poor souls. Okay, well, let's say your parents had set you up with $1 million trust fund so that your security is taken care of. They put $1 million in some kind of financial institution as a trust, and the nature of a trust is that you are never able to dip into, or that essentially the trust pays you the interest on that $1 million for your income. And let's say that you could get 5% income on your $1 million investment. That means that you get $50,000 a year without ever dipping into that $1 million. And on that basis, that $1 million trust fund is a renewable resource. You can use that $50,000 for as long as you like, and you'll never run out of that money. And $50,000 is pretty good. You can make a pretty decent living, living on $50,000 a year. But let's face it, your parents set up that account for you with $1 million in it, generates $50,000 a year for you. First year in university, man, I'd really like to drive a nice sports car. If I only had a nice sports car, I'd be so much more popular. Hey, I got $1 million, so why not buy a nice sports car? So you buy a $150,000 sports car. Suddenly, your account is down to $850,000, and $850,000 only generates about $35,000 in income per year. And at the same time, the insurance on your stupid sports car is $10,000 of that. So your expenses have suddenly gone up. And that means that you can't live on that $35,000, and every year you're going to dip further and further into the principal to sustain your standard of living. And so, consequently, suddenly your renewable resource becomes an exhaustible resource. As you dip further and further into the principal, your income will go further and further down, and unless you drastically adjust your lifestyle in order to be in keeping with that, sooner or later you're going to run out of it. And essentially, that's how renewable resources work. They likewise are renewable only insofar as that they're used within what biologists usually call their carrying capacity, or their sustainable yield. In other words, only insofar as you function on the basis of the equivalent of the interest. The problem with renewable resources is that while it's pretty easy to calculate what a sustainable use of your trust fund is, it's not that easy to figure out what a sustainable use of a fishery is. In other words, there are very strong tendencies by fishermen to overestimate how many fish there are and how many they're therefore able to catch. It also makes perfect sense that those fishermen are going to try their best not to get caught going beyond the carrying capacity. In other words, trying to fish a little bit more for their own income. In other words, there's strong dynamics toward going over the carrying capacity. The other problem is that the market doesn't deal with problems of exhaustion very well. What happens when, for example, the cod fishery went into rapid decline? What happens to the price of cod? The price of cod goes up. Now, what happens? What incentives does that create?
Fish more.
Yeah, it makes catching those remaining cod all the more profitable. And essentially, the upshot of that is that it leads toward the fate of the passenger pigeon. You all know about the passenger pigeon? The passenger pigeon, for those of you that do not know about it, was a bird that was native to this area of the Great Lakes that nested here during the summers and flew south to around Mexico, northern Texas in the winter. And early settlers in the United States used to describe the sun being blocked out for 2 or 3 days at a time during that migration because the flocks were so thick. Natives described hunting it by just throwing nets up in the air and catching it. Hunters in the mid-19th century described taking random shots in the air and dropping 10 birds with a single bullet because the flocks were so thick. The problem with them was that each pair of them only produced 1 egg per year. And in other words, the carrying capacity was relatively small. And in the in the second part of the 19th century, as the United States was industrializing, these industrializers, or the industrialists, were looking for cheap sources of food. And the passenger pigeon seemed to be an ideal cheap source of food, so they started being hunted. And essentially, from being a species that was here in enormous quantities, in a period of less than 50 years, it was reduced to, by the beginning of the 20th century, being essentially a trophy bird, meaning they were so rare that they were only hunted as trophies. And by 1911, the last one was killed in captivity, and they're now gone. Well, you get the general picture. Renewable resources are highly problematic, and renewable resources aren't just fisheries or birds, in this case, but things like land use,